Hello, my name is Jeremy Cooper and I'm a solutions engineer here at Nobl9. Today I'll be showing you a brief overview of Outsystems Architecture and how they can use AWS and Nobl9 to add SLOs to monitor their customer usage of their product. We'll touch on adding AWS Managed Prometheus as a data source and also create an SLO in Nobl9. OutSystems provides a high-performance, low-code development platform that allows customers to create and maintain complex enterprise applications. They're looking for a way to consistently deliver availability based on customer expectations. In addition, they are looking for a way to optimize when and how engineering resources are engaged by focusing on customer impacting issues. Here's a high-level diagram of OutSystems architecture. Their customers use a front end to manage their developments, which consist of using S3, DynamoDB, Redshift, and EKS. They leverage CloudWatch for infrastructure metrics and AWS Managed Prom to store their business metrics. The metrics are then pulled into Nobl9 in order to create SLOs. Now let's dive into Nobl9 and take a look at how OutSystems would get their data from AWS into Nobl9. This is done by data source integrations. Let's click here and create one. Here you can see all of the data source integrations that Nobl9 currently has. In this case, we're going to be using Amazon Managed Service for Prometheus. So we'll click there and we'll click on the agent, and then it asks us for some information. So we're going to enter the URL, which is given in the AWS window for our Prometheus, our Managed Prometheus instance. And then we're going to add the AWS region, which in this case is EU Central 1. We'll go ahead and put this in the default project, and we will give this agent a name. We'll just call it Managed Prom. And we'll give it a description. We'll just put demo. And we click Add Data Source, and this will take us to the details page. The details page is where you're actually given the YAML or the command line runtime for your Docker agent. So for Kubernetes, we give you the YAML. You can click there and copy it. And then for Docker, we give you the runtime. Now, what you will note is that you need to add your AWS key ID and your AWS secret access key. This is for authentication. So it's also why I'm not going to go further with showing you running an agent. But as you can see, it's very easy to get the connection up and running. You input a couple of lines of information, and then you're given the configurations needed to run this lightweight container, which collects the data via API. Once you have an agent configured, we'll be using one that I already have configured for this example, then you actually want to create your SLOs. That's the next step. So let's go over here and start creating an SLO. Once again, we'll click on this plus, and it takes us to the Nobl9 SLO wizard. From here, we'll walk through the steps of creating an SLO. The first step in creating an SLO is to choose your service. I'm going to choose the OutSystems service, and then we'll choose our data source. In this case, we're going to use AMS Prometheus, and we're going to create a ratio metric. What we're going to do is look at availability, and to do that, we're going to use a ratio. So for the good query, we'll be bringing in the 200 requests, and then for the total, we'll be bringing in all of the requests. And again, these are Prometheus queries, which are pulling data via API from AWS. Manage Prometheus. Next, we'll define a time window. For this case, we'll just make it 1 hour. In reality, you would probably make it 28 days. We will choose an error budget. I believe OutSystems wanted 99% reliability. We'll name the experience OK. Again, we're presented with the good query and the total query. And then at the bottom, we have the opportunity to give it a name. So we will name this, we'll just call it portal availability. We won't make it a composite SLO just yet. We'll add an alert policy, so it'll fire off an alert. I believe they're using PagerDuty, but we can send alerts to PagerDuty, ServiceNow, a variety of places, even a fully customizable webhook to trigger automation responses. But we'll set an alert for when it gets down to 25%. This is an availability SLO, so we'll add a label to it. You can have all sorts of labels for grouping your SLOs. If you wanted to have a hyperlink to have it take you somewhere, you could do that as well. You could drop off to a runbook or drop off to the original data source. And last step is to go ahead and click create, and we have created our SLO. Okay, so I'll admit I fast forwarded a little bit. I wanted the SLOs to bake in, but let's dive into our Outsystems service and look at its SLOs. So you can see here we have 3 SLOs, one for API availability, one for portal availability, which is the one you saw me create, and then the DynamoDB query latency SLO. If you remember, this is the one we created, good over total. For all the SLOs, no matter what the data source is or what the SLI is, we always display it to you with the reliability burn down, the error budget remaining, and the burn rate. So we want this to be very straightforward and simple so that anyone, even if they're not technical, can be involved in the conversation about preserving the error budget. Now, from this page, you can actually drill down a little bit deeper. And since this DynamoDB SLO seems a little more active, let's dig into it. This will pull up the details page. So the details page gives you some metadata about your SLO on the right-hand side. There you can see the labels, which we had created one earlier. You can adjust time views for the current SLO. You could go back a quarter or a year if you wanted to. We actually keep the data for over a year. At the top, you have your SLI chart. This is where you're seeing the SLI that we're bringing in, and you can see how that compares against the threshold that you've set for your SLO. Below that is the reliability burn down chart. This is where you can see how much error budget is left, and you can see how it's progressing. Hopefully you're not burning away error budget. In this case, you can see that some has been burnt, but since it's a rolling time window, we're actually recovering error budget. If you wanted to zoom in, you could actually do that, and then you could quickly zoom in a little bit closer on a particular time period. So in this case, you could see that there was an event that occurred, a little bit of error budget was burned, and down here in the error budget burn rate chart, you can actually see how quickly, the rate at which the error budget was burning. So from this details page, you're able to see the SLI, the reliability burn down, and the error budget burn rate, which is something that you can alert on. And that's pretty much it. That's how easy it is to get data into Nobl9, set up SLOs, and quickly be able to get information about them that can be shared amongst the teams at your company. Now, there are other things in the product to show you, but I don't have time for that. Thanks for watching, and if you want to give it a try, check out our blog post associated with this demo. We also have the Terraform modules created for you to help you get started creating your own SLOs. Nobl9 is available at nobl9.com with a free 30-day trial and also on the AWS Marketplace. Once again, thank you for your time, and we look forward to seeing you and working with you.